500 feet above a finished skyscraper, there is a machine still standing that helped build the entire tower, and now nobody on the ground can simply lift it away. It is too heavy for any helicopter, too tall for a crane on the street to reach, and too dangerous to just cut apart and drop. Below it, a city keeps moving, completely unaware that the hardest engineering puzzle of the whole project is unfolding quietly on the roof above their heads. Over the next few minutes, we are going to walk through the real 5-stage countdown that construction crews use to bring a giant tower crane back to Earth, including the strange moment where the crane technically has to build a smaller version of itself just to escape. Some of what happens up there sounds impossible until you understand the logic hiding behind it. No dramatic drone reveal, no dramatic music sting, just the actual staged sequence engineers rely on, broken down one day at a time. The final concrete has cured. The glass panels are sealed. The building is, on paper, complete. And yet the project cannot officially close because standing on the roof is a piece of equipment weighing several hundred tons with a boom stretching out wider than a football field. This is the exact moment when online comment sections light up with the same confident theory: just call in a heavy-lift helicopter and fly the thing away in pieces. It is a reasonable guess. Military and industrial helicopters really can carry astonishing loads, and news footage of them hauling entire vehicles through the air makes it look effortless. But a tower crane is not a vehicle. Its components are long, flat, and unevenly balanced, which turns them into the worst possible shape to carry on a cable. At 500 feet, wind speeds are also far stronger and far less predictable than at street level. A dangling steel beam in that kind of crosswind does not hang still. It swings, rotates, and can slam into the very glass facade the crew just spent months installing. Engineers sometimes describe this as an uncontrolled pendulum problem. The longer the cable, the wider and more violent that swing becomes. And at 500 feet, the cable has to be long enough that the pendulum effect turns nearly impossible to counteract in real time. Add the fact that most heavy-lift helicopters top out at around 20 tons, while a single major crane section can weigh 2 or 3 times that, and the helicopter idea quietly falls apart. It is not laziness or a cost-cutting shortcut that rules it out. It is basic physics refusing to cooperate. There is a second, quieter theory that shows up almost as often in the comments, that construction companies deliberately drag this process out over several days to justify a bigger invoice. In reality, the opposite is true. Every extra day a crew spends on a rooftop teardown is an extra day of labor costs, insurance exposure, and schedule delay that no project manager wants. If a faster, cheaper method existed and still met safety codes, it would already be standard practice everywhere. The staged, multi-day approach survives not because anyone profits from the delay, but because every shortcut anyone has tried against it has eventually run into the same immovable wall of wind, weight, and leverage. So if the sky is not the answer, the only place left to look is inside the machine itself. And to understand how it comes down, we first need to understand how it went up in the first place. Every tower crane starts small. In the early days of a project, a modest crane arrives, pours the first slabs of concrete, and sets the first steel columns. Then the building keeps rising, and the crane that once towered over an empty lot suddenly looks short next to its own creation. At this point, something happens that looks almost like a magic trick. The crane grows itself. Hidden just below the operator's cabin is a climbing frame, a heavy steel collar wrapped around the mast. Hydraulic rams inside that collar push upward, lifting the entire top section of the crane, the cabin, the boom, the counterweights, a few meters into the air. This creates an empty gap in the mast directly underneath. A new steel section, delivered by truck and hooked onto the crane's own cable, gets slotted into that exact gap and bolted firmly into place. The frame then lowers itself back down onto the new section, locks in, and waits for the next slab of concrete to be poured before repeating the entire sequence. Piece by piece, the crane essentially builds its own ladder upward, staying just tall enough to keep working no matter how high the building climbs. The whole operation typically takes a small crew, only a few hours per cycle, but it happens dozens of times over the life of a super tall project, which means the crane spends much of its working life, quite literally, rebuilding the ground it stands on, one steel ring at a time. It is also worth noting that the slewing ring, the large rotating bearing that lets the crane's boom swing in a full circle, and the counterweights at the tail both have to be checked and rebalanced after almost every climb, since even a small shift in height changes how the whole structure distributes its own weight. In extremely dense cities, where there is no open ground anywhere near the site, engineers sometimes take this a step further and place the crane's mast directly inside the future elevator shaft, right in the heart of the building. The tower is then poured in concrete around it, floor after floor, until the crane appears to be sealed inside a narrow stone chimney. This is exactly where a second wave of online myths tends to start. People assuming the crane is being welded shut inside the structure forever, either as some kind of hidden support beam or simply because removing it seems impossible. In reality, this internal crane was never permanently fixed to the shaft walls. It rests on temporary steel brackets that get repositioned upward every couple of floors, and once the tower tops out, the crane simply reverses its own climbing process, lowering its sections one at a time down through the very shaft it grew inside of, to be hauled out piece by piece at ground level. A related theory that circulates just as widely claims the leftover steel tube is quietly left behind on purpose, disguised as part of the elevator shaft's structural bracing, supposedly to help the tower resist swaying during hurricanes or earthquakes. It is an appealing idea, but tall buildings are engineered with their own dedicated damping systems for exactly that purpose, and a shaft still occupied by leftover crane parts would only get in the way of the actual elevator cars the building needs to function. The crane comes out, without exception, precisely because leaving it behind would defeat the purpose of the space it is standing in. But that clever trick only works for a crane hiding inside the building. The far more common situation, and the far more dramatic one, is a giant crane standing completely exposed on the open roof, with nowhere to hide and no shaft to climb back down through. This is the stage that makes engineers on other projects stop and watch. On the open roof, the main tower crane lowers its own hook one last time and lifts up the parts for a second, noticeably smaller crane. Workers assemble this smaller machine right at the edge of the rooftop and anchor it firmly to the building's structural steel with heavy cabling. Once the smaller crane is fully operational and tested, the giant one shuts down for good. Its job, after months of lifting concrete and steel, is finally finished. Now the roles reverse completely. The smaller crane begins carefully taking its larger creator apart, piece by piece. First come the massive concrete counterweights at the rear, then the long boom, then the operator's cabin itself, each lowered slowly to the ground below by cable. Watching this from a neighboring building, it genuinely looks like the machines are multiplying and shrinking on their own, which is exactly why so many casual observers online insist it must be some kind of visual trick, or proof that the construction company brought far more equipment than necessary and is now scrambling to hide the extra cranes. The real explanation is closer to a carefully engineered Russian nesting doll than a mistake. A large crane assembles a medium crane. The medium crane fully dismantles the large one and lowers it away. But the medium crane is still stranded on the roof, so before it can leave, it has to lift the pieces for an even smaller crane to take its place. This cycle repeats, each new machine noticeably lighter and easier to control than the one before it, because every rooftop has a strict weight limit. Two enormous cranes operating on fresh concrete at the same time would risk cracking the very floor holding them up, so engineers deliberately shrink the problem instead of trying to solve it all at once. Depending on how tall the finished tower is, this cascade might repeat only twice on a mid-rise building, or as many as 4 or 5 times on a genuine super-tall project. Each smaller machine in the sequence is sometimes referred to on-site simply as the helper crane, and its entire purpose, from the moment it is bolted together, is to make itself the newest, biggest problem on the roof, then hand that problem off to something even smaller. Seen from a distance without any context, it really does look like the building is quietly manufacturing machinery out of nothing, which is exactly why this stage tends to generate the most confused phone videos and the most creative theories online. Even with this careful staged approach, height never stops being dangerous, and one detail crews respect above almost everything else is how quickly conditions can turn. During one routine teardown on a mid-rise commercial tower, a crew was midway through detaching the rear counterweight blocks, several tons of concrete hanging from the crane's tail, when a sudden gust shifted direction without warning. The load swung sideways, just enough to shift the entire structure's center of balance. Bolts that had held steady for weeks began groaning under a completely new kind of stress they were never lined up for. The crew backed away from the platform immediately, and the operator of the smaller support crane released cable tension just in time to let the load settle instead of snap. Nobody was hurt, and the machine was back in position within the hour, but everyone on that roof walked away, newly aware of how thin the margin really is at that height. Afterward, the crew didn't just tighten the same bolts and continue. The entire teardown sequence for the rest of that day was recalculated, because a single unexpected gust had shifted the mathematical model the team was working from. This is standard procedure after any near miss like this one. Work stops, engineers recheck the load path, and only once the numbers agree again does anyone go back near the edge. When incidents like this happen, the public reaction online is almost always the same. Someone cut corners, someone bought cheap steel, someone was tired at the end of a long shift and missed a bolt. Sometimes that is genuinely the case. But more often, the real culprit is something far less dramatic and far harder to see: accumulated metal fatigue combined with a shifting center of gravity. A crane that has stood through months of sun, rain, vibration, and constant lifting is not the same machine it was on day one. Every single piece removed during teardown changes the balance of everything still attached, and if engineers misjudge that shift by even a small amount, the leverage created can be enough to tear steel brackets straight out of hardened concrete. This is basic lever mechanics, playing out at a terrifying scale. Move the center of gravity of a multi-ton structure by even a few centimeters, and the twisting force acting on its base connections can multiply many times over. It is the same principle that lets a small child on the long end of a seesaw lift an adult sitting close to the middle, except here, the seesaw is a 100-meter steel arm hanging above a city street. This is precisely why nobody rushes this stage, no matter how far behind schedule a project might be. Eventually, the cascade of shrinking cranes reaches a point where building yet another smaller machine no longer makes sense. What remains on the roof is little more than a compact steel tripod with a hand-cranked winch, weighing only a couple of tons. This is where the heavy machinery officially retires, and the most experienced rope access workers on the crew take over completely. Harnessed to the rooftop railing, working in cold wind with nothing but wrenches, mallets, and manual hoists, these workers dismantle this final structure bolt by bolt, relying entirely on physical skill and steady hands rather than hydraulics. From the street, this stage is easy to misread. Passers-by often assume this leftover tripod is left in place on purpose, maybe for future window washing platforms or emergency repairs after a storm, since taking apart something that small seems like a waste of time and effort. In reality, this last structure is broken down into pieces light enough for 2 people to carry. The steel tubes, the winch, the small platform sections are carried directly through the building's own finished doorway, loaded into the very passenger or freight elevator that will soon be carrying tenants and furniture, and ridden down to street level like ordinary cargo. No helicopter, no spectacle, just the last, quiet step of a carefully planned sequence. For the workers doing this final stage, there is a strange kind of anticlimax to it. After days of watching massive steel sections swing through open air, the job ends with someone carrying a wrench-sized bracket into a regular elevator alongside, quite possibly someone in a suit heading up for a meeting in the newly finished lobby. It is one of the few moments in the entire construction process where the most dangerous job on site and the most ordinary daily routine of the building briefly share the same small space. By the time the final piece rolls out through the loading dock, the roof that once held hundreds of tons of steel is simply empty concrete, swept clean and ready for antennas, mechanical units, or a rooftop garden. From the street, nobody looking up would ever guess that 5 distinct machines, each one smaller than the last, spent the past several days quietly replacing one another in a sequence most people will never notice, let alone understand. There is no dramatic drop, no final flight, no fireworks moment. Just a countdown that ends in silence. What makes this process worth understanding is not only the mechanics of it, but how differently it plays out depending on where in the world you look. In places where land is expensive, but not impossibly scarce, that external crane cascade is the standard method. In the most crowded downtown cores on the planet, where every square foot of ground is already accounted for, engineers lean far more heavily on the internal shaft climbing approach, threading the crane's descent straight through the heart of the tower instead of across an exposed roof. Neither method is universally better. Each one is chosen based on the tightest constraint at that specific site, whether that constraint is wind, space, weight, or simple neighborhood geometry. Engineers are already working on ways to make this entire 5-day sequence unnecessary. In research labs and pilot projects around the world, teams are testing automated climbing formwork systems that pour and reposition themselves with far less manual rigging, along with modular construction methods where entire rooms, complete with wiring, plumbing, and finished walls, are built in a factory and then stacked into place using compact internal lifting platforms instead of towering exterior cranes. Online, this naturally invites some bigger, more speculative claims. Some corners of the internet insist that within a few years, massive robotic printers will simply extrude an entire skyscraper out of liquid concrete from the ground up, the way a small desk printer produces a plastic model. Others predict fleets of autonomous cargo drones lifting wall panels into place with no human crew at all. 3-dimensional printing in construction is real and already used successfully for smaller, low-rise buildings. But for now, printed concrete alone does not offer enough flexibility or strength to safely handle hurricane-force winds at extreme heights, which keeps that particular idea firmly in the experimental stage rather than the mainstream one. Modular, factory-built construction is the far more realistic near-term shift, and it is already reshaping how mid-rise buildings get assembled in several major cities today. There is also growing interest in compact internal hoisting rigs, sometimes called climbing exoskeletons, that wrap around a building's own core and lift entire prefabricated wall sections into place from inside, rather than swinging them in from outside on a boom. The appeal is obvious: less exposure to wind, a smaller footprint, and none of the multi-day teardown sequence this video just walked through. None of these systems have fully replaced the traditional tower crane yet, and for very tall, architecturally complex towers, they likely won't for a long while. But on more standardized mid-rise projects, the shift is already underway. Until that shift fully arrives, though, the job of climbing hundreds of feet into open air to carefully dismantle a machine several times your own weight, one calculated piece at a time, remains one of the most demanding and least visible jobs in the entire construction industry. So the next time you notice a tower crane standing quietly above a finished building, remember that its story is far from finished. Somewhere in its future is a 5-day countdown of its own, a smaller crane waiting to be born from it, a set of bolts that have to be loosened in exactly the right order, and a final short elevator ride down to solid ground. The machine that spent months building a skyscraper skyward will, sooner or later, have to spend just as much care finding its own way back down. It is easy to look up at a crane and only see the beginning of a building. What most people never get to see is the quiet, carefully engineered ending waiting for that same machine. Proof that in construction, going up was never actually the hardest part.